So my name is Emil Svanberg. I work at RISE, the Research Institutes of Sweden. And I work on edge computing and data center related research innovation projects. And I'm going to talk about a testbed activity we have where we run edge computing in a 5G network context. So first of all, just a really quick framing of where we are and who we are. So I'm calling in today from the very northern parts of Europe, the northern parts of Sweden. So we're at 65 degrees north, just south of the Arctic Circle. So what we have here is lots of space, lots of cold, free air, lots of renewable power. We have hydropower in abundance here. And that caught the eye of the data center industry about 10 years ago, or a bit more actually. And it eventually led to Facebook decided to build a mega data center here. So just a kilometer away from me, back here, we have a massive Facebook deployment. I think that they have like 3 giant halls. I don't know the wattage or the power numbers, but it's a huge it's a mega data center for sure. And that also led to this region thinking about what are we going to do in this data center sector? We don't really have a strategy. And someone took charge of that and came up with a strategy. And one thing that came out of that strategy is that we need to have more research and innovation activity in the field of data centers. And so the result of that is the opening of what is today the RISE data center test and demo facility, where I am actually I'm calling in live from that place today. I'll talk a bit more about some of the equipment that's behind me here in a little while. So we have since about 2015 we have been running this test and demo center for data center related research and innovation activities. And let's see, I'm just going to look at this. Well, there are some other really interesting things happening in this region as well, based on the same things. Like we have lots of space, we have lots of green energy, and now the steel making industry is looking this way to turn from coal-powered steel-making plants to hydrogen-powered steel-making plants, and that is ongoing right now. And that's a huge initiative, and it would mean a whole lot. And there will be lots and lots of digitalization activity related to that as well. So this kind of sort of green transformation is really taking off around here. And altogether, we have a vibrant research, innovation, and startup community here centered around these topics. All right, so I'm going to stop the sharing for a little while just to show you a bit better what we have here. So I'm in the data center test and demo facility right now, and this corner behind me is our sort of edge test bed. And these are some of the experiments we have set up for like on the facility side and energy side and sort of industrial symbiosis side. So this here, it says box on the top. It's like an example of an edge node, what it could be. It has 2 full racks of IT equipment, and the box is connected to the black thing you can see in the back there, which is a water tank. So the excess heat from this edge node is used to heat the water in that accumulator tank over there. And then that energy is switched into the district heating system. So, and that's the kind of experiment that we do in here. There's another one here, the smaller cabinet there. It's a 1 rack size. It has an array of batteries connected to it. And on the roof, we have solar panels. Yes, it's true that the sun shines also here in the north of Europe. So we have that experiment going here. And all around me, there's this type of experiment set up. So a lot of things to do with sort of the facility side of data centers, and big and small, I can say. So edge for sure is part of that. Okay, so going back to the slideshow. Now you know a little bit more about who we are, what we do. More specifically on edge, what we do is essentially develop prototypes. It's not our job to build products. That's for someone else to do. We just want to facilitate innovation, and our approach to that is it's an experimental research approach. We've taken the approach that we want to show demonstrations of applications that will in the end drive the need for edge computing and the 5G networks more specifically. So we have kind of an application-centered approach so far, I would say, to what we're doing. So we have deployed an edge cluster, a prototype of an edge cluster running on OpenNebula, as I will show later, on the university campus. So that's another 500 meters away from here, much like Alfonso showed actually with the no, sorry, that was David that showed the university campus that was connected to a 5G network. So we have like a MEC host running there in the 5G network that's set up there. And we're also deploying these edge prototypes in other test beds. And we're working through a Swedish national program for innovation within advanced digitalization, which was set up by Ericsson, ABB, and Saab, fairly big Swedish companies. So they're driving innovation in a number of areas. So including circular economy, circular industry, I should say there, autonomous airports and autonomous mines. So those are kind of the industry verticals they're looking at, and we're there to supply basic digital infrastructure, including edge computing. So this is getting started now this year. So we haven't come very far still with that. In addition to the basic infrastructure, we're also doing a bunch of developer tools because, as I said, we take an application approach here. So we want life to be easy if you're an application developer. And opening up this in the world of cloud and edge computing and everything is quite complicated to build your application. You have to know lots and lots of things about the underlying infrastructure to be able to do it successfully. And if we can provide tools to smoothen that complexity out a little bit, then that's good. So far we've developed an SDK for Edge AI. So it's a media processing pipeline that helps you serve up your models running on the edge infrastructure. And we're also dabbling a little bit with something that we're calling it a meta operating system. It's a lightweight thing where you can kind of perform. It's an easy abstraction for distributed computing. It's a short way to frame it. Okay, so these are some of the example cabinets for the edge types of edge nodes we're working with. It's much more fun to show you the actual data center that I'm in right now. So let's just skip this. So diving into the 5G edge testbed at the university campus right over here, as I talked about, it's the Luleå University of Technology. We're working together with them on this. They are hosting the network. It is a 5G standalone network. I don't think we have millimeter wavelength, but we have lots of we're at the cutting edge of the features that are available or becoming available within the Ericsson product range for 5G, that is. Because this is they call it an innovation network. So Telia, the Swedish incumbent operator, they're involved in running the network. The university is kind of hosting it, and Ericsson is providing the equipment and the software. It has indoor and outdoor coverage, and as I said, it's standalone, and it's kind of like it's semi-open, you can say. So it's not really a lab, it's not a prototype, it is a live 5G network. Okay, moving on. In this or surrounding this network, we're building an innovation ecosystem. So we're using this as an opportunity to bring in partners to do demonstrations of all kinds, much like we were shown in previous talks here by David. So various research and innovation projects, we're hosting hackathons and events, making these resources available to students and others. Industry is participating by, in projects and also by putting up some funding for this. We have regional, national, and European level funding to go into this to make it a strong infrastructure. And we're involving stakeholders all along the supply chain here. So it's fairly complete innovation ecosystem. Looking more closely at the actual 5G testbed, this looks very similar to what David showed on the Spanish campus. So obviously things connecting to the network out here on the left, and then the access or the wireless interface, and then the 5G core connecting back to the internet and so on. And I'm showing the RISE infrastructure here. So the MEC host or the network edge here, and then we're also operating like basic cloud services from within here in the data center where I am right now. And together this kind of forms this device edge cloud compute continuum. And more specifically, if we look at this, we're connected here. The MEC host, or the edge infrastructure, is connected here at the local breakout point. So again, very similar to previous presentations. We're essentially a couple of switches away from the 5G antenna. So the latency here between the clients and the edge host is below 10 milliseconds. Whereas if we go all the way to the data center, we can measure at least I don't know, 30, 40, 50 milliseconds, maybe well below 100. So there is a big difference here in the latency. And this is something that we're focusing on when we're targeting applications. We want to find those real-time latency sensitive applications that really need 5G and edge computing. So that's our goal, at least. So again, that means we want to do real-time latency sensitive apps. They can be rich media processing, where you need to offload heavy compute jobs to a bigger infrastructure than you might have on your phone. We want to do AI at the edge, so we can serve up models and do inferencing at a more powerful edge infrastructure versus your own computer or handheld device. And these are some of the examples of applications that we have been working with. Again, they are fairly similar to what David showed. It was a very impressive demo by David. In fact, the last one here, the autonomous drone, the last one on my list, it has a very similar image recognition, or sort of object recognition and tracking application that we're using. And we're going to bring that from the campus actually to a mining environment. So that's quite exciting. So this is looking into the software stack, or the software setup, where we use ONEedge Open Nebula. So it's used here as a hypervisor on the edge clusters. So we're serving up Kubernetes and virtual machines. And this is our data center on this side here. And we have a number of these clusters out. One is deployed at the 5G network over there. We have one at the paper making factory, and we're looking to deploy many more going forward. So why then did we choose to go with Open Nebula and ONEedge? So this has been heard from the architect. So the Sunstone management approach is useful for us because we have several of these deployed, as you would in any edge scenario, really. And just being able to manage that via this one same interface, whether you use the portal or the API, that was a key thing for us. We have lots of open source experience here. We have lots of experience with OpenStack. So, but for this particular use case, it was easy to go with Open Nebula. And we use it to serve virtual machines as well as Kubernetes. And it serves our experimental needs very well. We also have some things that we can consider going forward. And we haven't yet tried to virtualize GPUs. Not sure it's supported actually by Open Nebula, but that's something we will be looking at. Federated authentication is something that we would enjoy as well. And we have this other thing is when the deployment scenario is complex and we have to traverse NATs, then one idea might be for the hosts to connect back to the Sunstone portal versus the opposite, which is, I believe, the situation today. So this was a bit of feedback, perhaps not expected in this session. All right. So what's next? Very quickly rounding this off. Open Nebula below ground. I don't know if we will be the first to do this, but we aim to go 400 meters below ground in a mine to deploy an Open Nebula powered edge cluster in a 5G enabled underground mine. So that's pretty cool. We have an ongoing project to do that. It won't happen this year, but it's probably in 2023. So that will be really cool. We're also looking more at sustainable edge cloud computing, like more sophisticated methods for dynamic orchestration and workload placement, GPU virtualization, as I mentioned, and long-time autonomous operations. And growing, deploying at more test beds. That's what we want to do. And we hope to bring Open Nebula with us. Thank you.